Hey guys, this is Siri and I'm back with another PyTorch video, and in this video we're going to be continuing our discussion on pre-trained models. Okay, so where did we leave off? Well, we first started talking about how we can use pre-trained models and use the work of some of the best researchers out there, and we said we were going to be focusing on computer vision, and we listed out the three main components or like three main functions or purposes of these models, whether it's pre-trained or not. And we talked about how there's this really large data set that many people use to maybe validate or validate their work or get their work kicked off. And we learned how we can import some of the most famous models out there using this simple import statement from Torch Vision import models. We saw a list. We talked about how these were the classes, and these capital letters were the classes, and these were the instances. You see the different numbers here representing the different layers and units. And we looked at we looked at two of these pre-trained models, and they were the AlexNet and ResNet. Okay, and we downloaded ResNet, okay, the ResNet 101, and we downloaded the weights. Okay, so these are the pre-trained weights that the researchers worked hard to train, and now it completely models the data that they were looking at originally. Okay. So we looked at the different layers, and we said that there were like 101, because there's 101 of these bottleneck layers, and you get some you get some probabilities and scores at the end. Okay, so what we wanted to do in this video is that we wanted to apply some transformations to pre-process the image, just make sure that they're the right dimensions and it's all good to go. Okay, so in order to do this, we can import transforms from Torch Vision. So from Torch Vision, import transforms, and these allow you to use some function-like objects, and they allow you to apply some transformations on the image, and it allows you to do some of the pre-processing that you would need to do. Okay, so we can create a variable called pre-process, and there's this transforms.compose, and this compose allows you to put together all the different transformations that you want to apply. And so we can do transforms.compose. Okay, and we're going to list a few of the transformations that we want. Okay, so let's do transforms.resize. Okay, so that's going to scale the image to whatever dimensions you want. And so let's just do 256. And if you just pass in one number, that means that the other dimension is going to be the same. So it's going to be 256 by 256. Okay. So that's what it scales the image to. And maybe let's do something else like transforms.center crop. Okay. And 224, once again, I'm only passing in one number because I want it to be like the same on both dimensions, like the height and the width. So we're talking about pixels here, right? So, okay. So what this does is that it scales image to 256 by 256, like we said. And you can probably guess that this one crops the image to 224 by 224, and you see the center, so it does it at the center. Okay, so or around the center rather. Okay, and then we can have some others. one of the most important ones that we'll be using throughout our machine learning journey, and these different videos that I'm going to make, right? So that we're going to be using tensor a lot. So what this does is that it converts the data that you have at hand. Most likely we'll be dealing with images, right? So it would convert that image to a tensor, which is um, a core data structure in PyTorch and many other deep learning frameworks. And this is a form that our model can take, okay? So, and it can actually pass in the data. So, transforms.toTensor is very important. So it just transforms your data into a tensor. Okay. So you see how handy this from Torch Vision import transforms is, right? It allows you to perform a lot of transformations. Okay, and another important thing is like to normalize your data, and we'll be talking about this normalizing in future videos. So this video, like this video and the last one, was mainly just like learning through examples, just taking a look at what's out there, you know, like taking a look at AlexNet and ResNet. Like I said in my previous video, we're not going to go through the nitty-gritty specifics of what's going on in each layer and what's going on in each step, but we're just like getting a high level overview of what's going on. And so what we're doing here in that high level overview is the transformations. Okay, so we're going to be doing that right now. So transformations don't normalize, and what this does is that it normalizes based on many different, or like several different aspects, and it just standardizes your data. Okay, so we can have a mean and a standard deviation. Okay, so let's set mean is equal to a set of numbers, and your STD is also equal to a set of numbers. And I'm going to put in a few numbers that were used during training. Okay, so during the training of this ResNet with the ImageNet, I believe. Okay, so mean maybe like 0.485. Okay, so these were the values used. Okay, 0.456. Okay, and 0.406. Okay, so that's for the mean. And 0.229. 0.224, and we're using these numbers so that we can get like the best results, because these are the ones that were used during training. So okay, 0.225, and this is to normalize the RBG condition, so the red, blue, and green. So you know how each image has, you know, different color channels, right? So if you have a colorful image, right? Just one that has color, that's not black and white or like gray. It's not a grayscale image. Each pixel can probably have like 3 values, right? One that tells you the intensity of the red, the blue, and the green. And in order to normalize and standardize all that, we're going to need to pass in some mean and standard deviation values. Okay, so that's what we're doing here. Okay, so now you see like how Torch Vision's Torch Vision modules help us do this, especially this transforms right here. And if we run it, I forgot my commas here. Okay. Mean. Okay, here too. Oh, I didn't. It's funny. I didn't put this in the parentheses, and I was supposed to do that. Okay. Finally. Okay, so cool. Okay, let's just try something here. Okay, let's compose. So this just like puts together nicely all the different transformations that you want. And you can do them separately and individually too if you wanted to, but if you wanted to apply a set of transformations, then you would need to use the transforms.compose. Okay, great. Let's do something with it. Right, let's pass in an image. And by the way, I already downloaded an image called bobby.jpg, and like I'm sure if you search online, you can find a similar image too, or the same one. Okay, so if you wanted to code along and do something like that, you could search up a bobby.jpg and like just search PyTorch along with it, so you'll find an image like that. Okay, so from PIL, we're going to import image. Okay, and we'll set our image equal to the image. So we use function that our image object has, and we'll use it to open the image up. Okay, so the title of my image that I downloaded is bobby.jpg. Okay. Okay, so let's show the image. Okay, JPEG. Okay, give me 1 sec. I'll be right back with you. Okay, I'm back. And this was the image that just opened when I clicked on image.show. There was just a minor problem. Like it was in the wrong spot, so I couldn't just type in bobby.jpg directly. I would have needed to type in the path, but now that I moved the image to the current place that I'm at right now, current directory, it's all good. Okay, so you saw the image. It was pretty cute. Okay, so let's pre-process it. Okay, so let's say the image T, and the T is going to be standing for transforms, or transformed, the image that is now transformed. Okay, and we're going to pass it into our pre-process function, sort of function-like object, right? So we can pass in our image, and all is good. So let's import PyTorch. Did we import torch yet? Probably did. Oh, we didn't. Okay, so let's import torch, and say that batch transform is equal to torch.unsqueeze and image t. Okay, 0. And so what this does is that it adds an extra dimension. So now when you say batch t.shape, you see, okay, first of all, wait. So we have image. Okay, we don't need to show the image again, but like when you say image.shape, okay, it's an image, never mind. Okay, by the way, so it adds an extra dimension of 1 because not only do we need the 3 dimensions, like for the 24 by 24, or 3 by 24 by 24, we also need the dimensions that specify the number of images or samples in a batch. And a batch, is just the number of samples that you're going to be passing into your network at once. and so you'll be updating your parameters according to that. Okay, so, but we don't need to worry about that now. What this just does is that it tells you, it adds an extra dimension of 1. That's what unsqueeze does. It just automatically adds in a 1 at the index that you specify it at. So you have a 0 here, it specified it at index 0. If you did it at like, so 0, 1, 2, and then 3, then the 1 would, what did I do? Then the 1, what? Okay, so 0 is that, and then 3, see, you see the 1 got pushed back to the 3rd index, so 0, 1, 2, 3. Okay, so that's what unsqueeze does. Okay, and the 3 stands for the 3 color channels, the 24 by 24 stands for the height and the width, and we, like that's the height and width of our Bobby.jpg. Okay. Okay, great. Okay. Okay, cool. So now let's do something like this. Let's do resnot.eval. And what this does is that if you want, well, first, if you want to do some inferencing or inference, right? And this just means running your trained model on some new data. And remember, this is already trained. It's pre-trained. This is a pre-trained model. So, and we already downloaded the weights that were associated with this pre-trained model. And so now we have a fully trained model. And so now we can pass in a new image. Okay. And so the reason why we're doing resnot.eval, okay, this doesn't actually pass it in yet, but if you want to pass in Bobby.jpg, which is a new piece of data, then you have to set your ResNet or your model, any model in general, in eval so that things don't go wonky with your batch normalization or like dropout and other sorts of things. Okay, so in order for those things to work out, you're going to need to set it to this setting. Okay, eval mode. Okay, so now ResNet is not defined. Okay, maybe I need to run this again. Maybe I need to run the whole thing again. Okay, so let's import that. Okay, so now you don't see all that downloading stuff because we already downloaded it in our previous video. Okay, you got the same stuff. Okay. Okay, great. So you just get ResNet again. Okay. So now let's create our output. And output is going to be, so once again, let's do the same like f of x sort of example, right, where we have f of x is equal to x plus 2. Like f of x is the model, except it's just a tad bit more complicated than that. But let's just pretend that f of x is equal to x plus 2. Our f of x is the model, and our x is the input, and then we get an output, which is like x plus 2. So we pass in 3, which is our new data. We pass in our new data, which is 3, for example, in our f of x plus 2, and 3 is just like a random number, right? So we pass in 3 into our f of x, just like we're passing in our batch t into our ResNet model, and we're setting that equal to, or we're setting output equal to the output of ResNet when you pass in the transformed and nice version of Bobby.jpg that our model can take in. So now when you run this, and let's just print out output at the end. Okay, we get a whole bunch of tensors. Or actually, we get a whole bunch of values. Okay, and you see this grad fn at the end. That has to do with our gradients and like back propagation and the actual training that's going on. Okay, but yeah, okay. First, okay, and I also have a text file called ImageNet classes. And so these are all the classes of our ImageNet. And remember, our ImageNet is like a data set, right? I don't know if I mentioned this or not, but it has 1,000 classes. And remember what we talked about, what classes were, right? Like the different categorical values. So for example, if you have elephant, giraffe, rhino, then each one of those would be different categorical values, different labels, or different classes. And so we have 1,000 of those in ImageNet, and and I have a text file that has all of those classes. Okay, so I would recommend downloading that so you can code along as f. Okay, and labels is equal to line.strip. Okay, and we'll talk about this in just a second. For line in f.readlines. So what's going on here is a simple list comprehension, and what this line.strip does, and by the way, line is just like each line in the text file that we're talking about, and we're just saying like whenever we say f, we're going to be referring to our ImageNet classes.text. So f.readlines is just like the different lines in our text file. And so for every line in our text file, let's just like get rid of all the spaces or any specified characters that we pass in, which we didn't. So let's just get rid of all the spaces. And when we do that, we're going to, by the way, this is a list. So we're going to have a list of our labels. Okay, so this is like some list comprehension that's going on here. Okay. Okay, cool. And so now, so what we're trying to do now is we're trying to find out which class has the highest score. So we have like different probabilities here. So I think I mentioned in my last video that our output is going to have like a different score / probability that's associated with each of our different classes. And when we pass in the image, we're going to get like 1,000 outputs, 1,000 items in our output, which just represent the different scores and different likelihoods that our image is that specific class, and the highest likelihood, whichever index has the highest likelihood, is the index of our image that we just passed in. And so we're hoping for our dog output, for our dog probability to be the highest, because that's what we passed in, right? We passed in Bobby.jpg and he was a dog. So yeah, that's what we're expecting. And so the maximum score that we get in this output correlates to the highest probability. So we want to know what the image is, or at least what's most likely, so we can find the max score. Okay, so yeah. So x is equal to torch.max out and then 1. Okay, and by the way, I know this might be confusing for many people like, what's this like underscore? Well, it's just like if you don't think you're gonna use it, or if you don't anticipate that you're gonna use this in the future, whenever you're writing the code, whenever you're writing some more code in the future, and you don't think that you're gonna use this value, don't bother giving it an actual name. Just do an underscore. So yeah, so let's run that. Wait. Okay, excuse me for one more second. I'll be back in just a moment. Okay, so now it should be in the right spot. Okay, good. Okay, so now we can use this softmax function, and the softmax gives you all the probabilities that we need, and we're going to be talking about all of these different layers in depth in another video, like softmax, all these activation functions, and like what each of these different functions and sections of our neural network, which is just a mathematical web once again, what each of those different layers do. Okay, so let's not worry about that too much, but softmax does give you the outputs and the probabilities. Okay, so let's say that percentage, right? Because we're getting probabilities anyway, right? So let's just call it a percentage, and torch.nn, which is an important module that we're going to be talking about. It has all of the neural network components and all of the different building blocks that we'll need. Okay, dot functional, dot softmax. Okay, and we're going to be dealing with our output, and we're going to be going along the first dimension, which is actually the second dimension because it's a zero-based index system, right? So, okay, and let's multiply it by 100 because it's a percentage. Okay, so labels index 0, okay, and percentage index 0 dot item. Okay. Okay, so when we run it, okay. So I'm just talking about the first item, okay? And it accurately predicted that Bobby was a golden retriever, and it can say this with 96% confidence. So that's the probability that that Bobby is a golden retriever. Okay. And if you want to take a look at the top 5 max scores, so these were the top 5 things that our model thought that Bobby was. So obviously the max is the golden retriever, which is why we got this output. But if you wanted to do something like this and torch.sort of the output, and then let's do descending order. So we want the highest probability to go to the lowest probability. So descending is going to be equal to true. Okay, okay, it's going to be a long list comprehension here, so bear with me for a second. So labels, then IDX, comma percentage of the index that we're looking at, dot item. And the dot item just like retrieves our like the actual item for us. So, okay, and then we're going to do that for every index in indices from 0 to 5. From 0 to 5. And recall that, like, we are dealing with the two-dimensional thing right now. So when we run it, we'll get the top 5 things that our model thought Bobby was. Okay, so we see a golden retriever, we see a Labrador, a Cocker Spaniel, and Redbone, and a tennis ball. So maybe this one should be, like this one isn't that accurate, right? So, yeah, but that's okay. Like golden retriever was number 1, so yeah, that's good. Okay, so yeah, this was a good exercise. We passed in an image into a pre-trained model, and we did some pre-processing and some like normalization, and we converted it to a tensor, and we did some like resizing and cropping, and we applied some settings on it, and we created a variable that could store our output. You see all these different values in our tensor here. And we got to see that he was a golden, he or she was a gold, it's Bobby, okay, a golden retriever. Okay, so yeah, I hope that was helpful. I hope like these 2 videos on pre-trained models were helpful, and now I hope that you got a good understanding of what pre-trained models are, what a few examples of them are, and how we can use them at least on a basic level. Okay, so yeah, I hope you learned something new today, and I'm looking forward to seeing you next time. Thank you so much.